Okay, so this is the second day of lesson 8, and we're going to do more real-life problems, and this is more about harmonic motion. So this is something that kind of, for the most part, like something on a spring or a piston that goes up and down and up and down. Not so much like a bouncy ball, because the bouncy ball diminishes. This is going to pretty much follow the same pattern. And yes, a spring, if something's on the end of a spring, it does diminish, but that's not. We're going to, for the most part, it's going to stay pretty consistent as you go. So, the definition of simple harmonic motion is a point that moves on a coordinate that is said to be, coordinate line, that is said to be in simple harmonic motion if the distance or displacement d from the original origin at time t is given by one of these. Now remember, a sine and a cosine are pretty much the same thing, just with a phase shift. I could, if it's written as sine, I could write it as a cosine with a phase shift and vice versa. So typically we would just use sine. So this is the main one, is sine, where a and b are real numbers such that b is greater than 0, so we don't want to have a negative in there. Okay, so the motion of the object has the following properties. Probably remember these early on. If the number is out front here, that's the amplitude. We called it a vertical stretch or vertical shrink is what we originally called it. For this, we're going to think of it more as an amplitude or just a displacement, how far away it is from the center. The period, if I want to know what the period is, I take this number, take 2 pi divided by that number. That's something we did on day 1. And then the frequency was just the inverse of that, or the reciprocal of that. It means if you flip it over. So if you take the period and flip it over, you got the frequency and how many cycles per second or per whatever time period you're talking about. Okay, so if you want to maybe look back at day 4, kind of review those a little bit, just how we graphed and what those numbers meant. We had more numbers involved in that, but we're going to stick with just an A and a B for this simple harmonic motion. So the first problem here, the displacement is just that's how far, think your amplitude, how far away from the center it can get. So if this is a piston or a spring, weight, it's going to go up a certain distance and it's going to go down the same distance. Well, that's your A. We think of it as an absolute value. It doesn't matter if it's positive or negative. And that all comes from the amplitude. So when this is following the motion of this function, the d equals 6 sine 3 pi over 4t, the maximum displacement on this would be that 6. So it's going to go up 6 or down. It doesn't really say inches on this one. They didn't give us enough information, but it's going to be 6 units. Okay, now the frequency on this, remember the frequency is b over 2 pi, b over 2 pi. Well, this is the b right here, so this would be 3 pi over 4 divided by 2 pi, which would be the same thing as 3 pi over 4 times 1 over 2 pi. So the pi's would cancel. This would be 3 over 8. Okay, so the frequency is going to be, this would be like 3/8 of a cycle per second, and t's being the number of seconds. Find the value of d when t equals 4. Just plug it in. You'll just simply plug that in. So it would be 6 sine 3 pi over 4 times 4 over 1. Plug it in for t. Well, the 4's would cancel. So my calculator, I would just type in 6 sine 3 pi. And that ends up being 0, which just means after 4 seconds, it's back in the middle. Maybe it went up and down, and now it's back in the middle. Now find the least possible value of t for which d is 0. So basically, when's the first time that it's in the middle? That's what it's asking. Well, you can set it equal to 0, and you'll find the first one. Because you could find the rest of them by adding whatever the period is. So we could have some n there plus so many pi n to find all the times it equals 0. But the first one, the least possible value, is just set this, put a 0 in here. So 0 equals 6 sine 3 pi over 4 times t. Now if I divide both sides by 6, I'd still have 0 equals sine 3/4 pi t. To get rid of the sine, take the inverse sine of both sides. So I'm going to inverse sine this would be 3 pi over 4t, and that's going to equal, if I do the inverse sine of 0, that's 0. Now if I multiply the reciprocal over, it's going to still equal 0, so t equals 0. So this actually starts at 0. So that's the first time it's in the middle. Okay, backside. Now we're going to write the equation. The first one we were given the equation, now we're going to write the equation. So just remember this is A sine BT. And keep in mind that, I'll write it up here, even the frequency equals B over 2 pi, and the period equals 2 pi over B. Okay, so write an equation for a simple harmonic motion of a ball that starts at equilibrium, so it's going to start at 0. And that's, sine starts at 0. Remember when you graphed it, sine came up and went back down. So that's why I'm going to use sine on this one. With a maximum displacement of 10. So the furthest away from the middle it gets is 10. Well, right off the bat, there's my A. My A equals 10. And the period is 4 seconds. So if I want to know what B goes in here, that means 2 pi divided by B equals 4, because period equals 2 pi over B. So multiply B over, I got 2 pi equals 4B, and then divide by 4. So B would equal 2 pi over 4, which is a half pi. So this would be 10 sine, and then parentheses, pi over 2t. Okay, so there's my function that I could find all kinds of other things about. Oh, I didn't answer the question, did I? What's a frequency then? So what's a frequency? Well, if the if the period is 4 seconds, that means it would be 1/4 of a cycle per second. So that would be a frequency, would be 1/4. Again, the period, just flip it over. If the period is 4 seconds, the frequency is 1/4 of a cycle per second. A weight is suspended from a spring and is set into oscillating motion by compressing it to a point of 3 above its position and then releasing it. So it takes about 1 second for the weight to complete one cycle. So if we're going to write, let's just write the function here. So the highest of the A would be 3 centimeters. It's going to be put 3 centimeters up. And then it takes 1 second for that to cycle through. And then if it takes 1 second for the weight to complete one cycle, and I want to find out that B is, well, I kind of think of it either way here. If it's 1 second for one cycle, that means the period is 1. It also means that the frequency is 1. So you can kind of go either route you want with this. So if I'd say the frequency is 1, that means 1 equals B over 2 pi. So that means B equals 2 pi if you divide it over. So this would be, so displacement equals 3 sine of 2 pi t. Number 4, suppose a ball at the end of a spring undergoes a simple harmonic motion where 8 centimeters is the maximum displacement. It takes 8 seconds for it to go up and all the way up, down, all the way back up again. Write the equation. So that 8 seconds, the 8 centimeters is your displacement. So that'd be 8. And then if it's 8 seconds for it to go all the way up and then back down, it means your period is 8 seconds. That equals 2 pi over b. So let's solve for b. If I bring the b over, that'd be 8b equals 2 pi divided by 8. So b equals pi over 4. So this would be pi over 4t. Now find the displacement after 20 seconds. Plug a 20 in there. So sine pi over 4 times 20, which is really 20 divided by 4 is 5. So you just do 5 pi, 8 sine 5 pi. Plug in the calculator and equals 0. So it happened at that point, it came back to 0. What is the least value of t? So at what time is it at 4 seconds? At 3 centimeters. So at what time is it at 3 centimeters? So set this equal to 3. So if I divide the 8 over, I'm just going to do this to save some space, and then do inverse sine. So inverse sine of 3/8 would equal pi over 4 times t. And if I'm trying to solve for t, I'd actually multiply this by 4 over pi over and solve for t. So I put that in the calculator. That means t would be 0.489 seconds. So it took about half a second for it to get to 3 centimeters. See, what is the frequency of this? So the frequency, well, if it took 8 seconds, we kind of go different routes here, but if I use that, if that's pi over 4, that's b. So the frequency is pi over 4 divided by 2 pi. You could do it this way, divide and get your answer, or if it took 8 seconds to go up and down and back up again, that means per second it was 1/8. 1/8 of a cycle. I can't spell cycle for some reason. Good grief. I'm trying to go really fast here. I got a few minutes to record this video. So, or over here, if I multiply, this would be the same thing as pi over 4 times 1 over 2 pi. The pi's would cancel and it's 1/8. So either way you look at it, it's 1/8. You know, if you look at it as 8 seconds to do a full cycle, that means 1/8 of a second, or 1/8 of a cycle per second, or you could use your b and divide it by 2 pi. So either way you look at it, you get 1/8 of a cycle.